Yeah. Regarding quizzes, is there anything like best two of three
What?
out of the? Yeah, we have three tests, right? Sir?
I didn't get it. What is that you have?
Yeah, we have three tests, quizzes, three quizzes, no?
Yeah, yeah, yeah.
Yeah. So is there anything like best two out of three?
No, no, no. There is nothing like that. As I said to you before, also there is nothing fixed. Everything is flexible. So depending on if suppose somebody could not attend one test or two tests, depending on that, so it will be decided case by case. But do not assume that your grade will be based on base 2 out of 3. Don't assume that. Okay, try to perform well in all the class tests or all the exams. So like in general, like in offline situation, we have usually 4 tests. So one is end sem, one is mid sem, and there are 2 class tests. One is before the end sem and one is before the mid sem. But here it is approximately 3 or 4 class tests. But yeah, so that will be decided later on. So don't miss anything. Do not assume anything. Okay, do not assume that there will be base 2 out of 3 or base 3 out of 4. Don't assume that. If you are missing some exam due to certain reason, you should immediately contact to your, you should immediately write an email to me, or you can write an email to Professor Somesh Kumar, CCing to me, saying the reason why you won't be able to attend, okay, the exam, if there is anything like that. But you should make sure that you perform well in all the class tests. Yeah.
So will this today's lecture will come in exam or not?
Yeah, I told you the syllabus. So whatever we'll be discussing, if it is a part of the syllabus, then it will come. In fact, whatever we have decided, whatever we have discussed till last week, everything is included in the syllabus. And tomorrow also we'll continue the discussion because, yeah, so last day we introduced the concept of moment genetic functions, but we did not discuss the properties of it and we didn't solve any problem regarding that. So we'll do it today. So of course it will be a part of the exam in that case. So you know the syllabus accordingly. You have to decide. So today, I'll see today if I can do something which is beyond the syllabus, or depends on time. Whether I'll be confined myself to only to discussing about the things, the topics which are included only in the syllabus for the exam tomorrow. So yeah. So but you know the syllabus, so which I discussed yesterday, and also it is available. Yesterday means last week, and which is also available in the document which is shared you, the first document which is shared with you, like syllabus, detailed syllabus, something like that. So it is the syllabus for the class test 1, or the first class test. Okay, it is discussed there, so you can just have a look. Or just I think last day also I discussed it here. And moment generating function is a part of it, which I started discussing last day, and I'll continue discussing it today as well. Okay. Any other quick question regarding the exam? And I think I also have shared a document regarding exam. So there will be numerical, the answers will be numerical numbers, numerical values. So there will be some kind of a box, okay, where you have to write the final answer. So all problems are all numerical type. Yeah.
So my Moodle is having no channel with name probability and statistics.
Then how are you attending the classes? Oh,
No,
in
sir,
Moodle.
Moodle.
Okay, okay.
Yes.
Yeah, so you should receive an email from the Moodle, what is called, because I did not open any channel there in Moodle. Maybe because of that, I don't know. What about others? Did you have anything like that, provided services, or no?
Yes, sir, we are having. For me, it is there.
Okay, it is there. Okay, maybe I don't know. Maybe Professor Somesh Kumar, the coordinator of the course, has opened a channel or something like that there. So, but if you don't have it, you can drop you can drop an email to me. I'll just see. I'll talk to the Moodle person whether it is due to some administrative reason or not. I think that must be some due to some administrative reason. Like I don't know. So yeah, because I didn't open any account there. So or any channel or whatever it is there. So yeah, so you should drop an email to me. Then I'll forward it to the concerned person, and maybe he or she will get back to you. And you should definitely get an email regarding the exam. Okay, So regarding the password, username, this kind of stuff with all the details, you'll receive an email. I mean, whatever we have experienced, let's say last semester, the same procedure will follow. So before the exam, you will probably receive username password for your module for appearing in the exam. And that will be valid for 1 hour, like 12 to 1. Yeah. But if you have any problem, you should immediately write an email to me that you have some issues, and then I'll forward it to the concerned person. He or I will get back to you through email. So you always have to be active, or so your emails, I mean, you should access your email all the time. Okay, if there is an issue, so then you should drop an email to me and you should wait for our reply. Okay. Okay, so what we discussed last day towards the end is basically the what is called the moment generating function of a random variable. Okay, moment generating function, moment generating function of a random variable. So it is for both, like for discrete random variable or continuous, and it was just defined as this. So it is like a function from R to R, so real to real, and it is defined as this. This MT, T is the variable here, which is expectation of e to the power tx. Okay, where x is the random variable. Okay, so and it was defined as this way. So if it is for discrete, then it is sum of e to the power tx, fx. Fx is the PMF, and x belongs to Rx. Rx is the range set of x. So when x is discrete, and it is integration minus infinity to infinity to the power tx, fx dx, if x is continuous. Somebody's microphone seems on. Please switch off your microphone. Yeah. Yeah, great. So yeah, when x is continuous. Yeah. So what we have observed, I mean, the reason or the advantage of having this kind of a function is that. So what we discussed is like we can, if we want to calculate the moments of, let's say, the kth order moment of, let's say, the nth order moment of this x, the random variable x, then every time we have to perform certain kind of summation, certain kind of addition, and then, or certain kind of summation or certain kind of integration using the formula. So here, using this function, if you know somehow this function, we'll see it later also for when we'll study different kinds of specific random variables, specific distributions, like when we know the fx, okay, for certain kind of random variables, then maybe sometimes it will be advantageous or convenience for us to calculate directly the moment generating function, and from the moment generating function itself, we will calculate all possible moments. So any nth moment for all values of n, like n equal to 1, 2, 3, and so on. And that's how we can also calculate the expectation variance and so on. Okay, so this is the purpose. So purpose of having this function is that we can calculate all possible moments. Okay. Now, what I mean, yeah. So we have seen that, and here also we have seen that you can do it like this. So like sum over x to the power n fx dx. I mean sum, and then this is integration x to the power n and fx dx and so on. So we have seen this. This is for discrete. This is for continuous. So what is happening here? As you can see that these are. I can treat this. I can say that this is a function of x. I mean I can consider a function. Let's say gx. Okay, it is any function, or you can just write, yeah. So some function gx, okay, which is x to the power, which is defined as some x to the power n. And as if I am putting this, so when I'm replacing this small x by the capital X, so it is giving me like gx equal to x to the power n. Similarly, if I consider function gx, which is, let's say, e to the power some tx, t is any constant, let's say, then I can have gx is equal to e to the power tx. Okay. So as if I am replacing this x with this small x with the capital X, the random variable, and then I am calculating the expectation of this function of the random variable. Okay, so I can treat this g. Okay, I can call this g as a function, as a very special function. For example, it is of a like of this kind of function like x to the power n, or it is e to the power tx, t times x. So g is like a function. So in that case, the interpretation is like I'm as if I am calculating the expectation of a function of x. Okay, and this function is defined by, for the case of moments, this function is x to the power n, or you can just write capital X here, or it is e to the power tx. So yeah, so there is actually a general theory of functions of random variable. Okay, functions of a random variable, and that we'll discuss later on. But here you get a flavor of it. Like it is not very specific, like e to the power tx or x to the power n. I can in fact consider any function of the random variable, and then I can possibly consider computing the PMF or PDF, expectation variance. I mean, all kinds of things, whatever we are doing for this random variable. So for gx is then again a new random variable that you can interpret it like that. This is a new random variable. Okay, so you had a random variable x, capital X, and then you create a new random variable which is gx. Okay, in fact, you also have studied, we have also seen that g of a x plus b, okay, is equal to a times ex plus b. Okay, but this is again a function of x actually. So this is the corresponding gx is like ax plus b, just a linear function. Okay, if you plot it in x-axis, y-axis. So yeah, so here also this is a function of the random variable capital X. Okay, so in general there is a theory that if you have a random variable, you can talk about functions of that random variable, and that is also a random variable, and then you can possibly calculate different characteristics of that new random variable given by the function g. Okay, so there is a general theory, and this is very important. We'll discuss that later, because what will happen is, okay, so that if so this function g is sometimes interpreted as a transformation to the random variable, and so if there is some kind of random variable, there is some kind of a data, and then possibly you would also like to know, if I transform this function into a different kind of function, what kind of analysis you can do for the data. So yeah, there is a general theory for this, and these are very special cases of that, like moment for x to the power n, the function, this is e to the power tx, and you also have seen that this is this ax plus b is also a function of x. Okay, so there is a general theory for that. We'll be discussing it a little later. Okay, I mean once we discuss different kinds of specific probability distribution corresponding to some specific random variables. Once we have that, then we'll try to see that whether those random variables, those specific probability distributions, are also related among each other or not. Like whether one particular specific distribution is a special form for other probability distribution or not in disguise, or how they are related. Maybe one PDF or PMF of some particular random variable, okay, is a function, okay, of a random. I mean, it is a PDF of a PDF corresponding to a function of that random variable. Okay, so those kind of stuff we'll be discussing later on, but I'm just telling you that this is what you can expect from here. Okay, if you just look at it, you can see that these are the functions. Okay, and then we said, okay, we did not prove it, but we said, okay, from MGF you can get all the values of the moments from the derivative of this function. So this is you have to remember that this is a function of t. It is a new variable t. T is nothing to do with x. It is just a function, but t is the variable. Okay, so let us just prove that how we get all the moments from this moment generating function. Okay, so this is the idea here. So we have MT. I mean, I will not give you a detailed proof, but okay, so you can find it out. Like this is very simple. Anyway, so this is expectation of e to the power tx. Now, if you want to take a derivative of this function with respect to t, like d dt of mt, if you take a derivative of this, see if you write down the formula here, then you will see that this is this kind of a function. Okay, this kind of a function, or this kind of a function. Now, if you take the derivative of this, okay, with respect to t, then this will not affect on this one, but it will only affect on this one. Similarly, it will not affect this fx, but this will only affect dx, e to the power tx. So you can actually see that if you just write, which I'm not writing, that this is nothing but d dt of e of e to the power tx, which can be written as expectation of d dt of e to the power tx. You can just see using the formula of this that actually exponential expectation will I mean this ddt can be included inside the random variable. Okay, so that can be followed from this definition itself. You can just have a look. Okay, so this means what? This is expectation of x e to the power tx. Okay. Similarly, you can take the derivative of like this. So the second derivative of this, if you take that mt of the moment journey function, then it will be okay. So second derivative with respect to t, expectation of e to the power tx, and then this will be expectation of d2 dt square e to the power tx, and so this will be expected value of x square e to the power tx. In fact, if you keep on doing that in general, okay, the general formula for any nth derivative with respect to t for mt, the function mt, will be this dn dtn expectation of e to the power tx, which can be written as expectation of x to the power n e to the power tx. Now, to set t is equal to 0 in this derivative of mt, okay, or nth derivative of mt, then what happens is you can write dn dtn mt at t equal to 0. So this is expectation of x to the power n e to the power tx, okay, at t is equal to 0. So this is nothing but expectation of x to the power n. So that means this is the nth moment of the random variable capital X, and then that is nothing but the derivative, nth derivative of this function at t equal to 0. Okay, so that means from the moment generating function, you can obtain the nth order moment or the nth moment of the random variable capital X. Okay, let us see some examples and then we'll see what is happening here. So this is the use of this moment generating function. Okay, let us see some example. Okay, suppose we have a random variable whose PDF is this. Now say one thing to notice here is whenever we consider random variable, we start with a PDF or we start with a PMF. Okay, we do not know where it comes from. Okay, what is the corresponding random experiment? In fact, we don't bother. Okay, because so there is an underlying probability space, there is some random experiment, there is a random variable, and now we know the PMF or the PDF. Okay, so how it is obtained, we don't know. But suppose in a case of real data, you have to find the probability density function or probability mass function. Okay, maybe you do not know the process also, how the data is obtained. That could also happen. Okay, so you do not know how it is, how the data is. I mean, you do not know the details, the precise details of how the process, that how other experiment, how the data is obtained. But you are given with you are supplied with the data. Okay, you do not know how it is obtained. Then the question will be, what is the possible PDF? Okay, that you will get some particular value. Okay, some particular x. What is the probability of that when it is discrete, when it is continuous? Okay, what is the possibility? What is the probability? Not possibility, what is the probability that some value, some particular data points will lie inside a range? Okay, when you talk about the continuous random variable. Like if it is a real data means, I mean, suppose the data points are real value, I mean, the real numbers, okay, then this is the case. But you can have vectors, okay, as the data points. In that case, we have to extend this analysis. Whatever we are doing, it is for a single random variable, one variate random variable. Then we have to extend this analysis, which we'll do in this course for two random variables, for a pair of random variables, okay, that we'll do next. But in that case, your data points could be like two-dimensional vectors, Okay, like here, it could be the data points like here. These are the data points, let's say, and then you have to perform some kind of analysis. Okay, for example, you want to in a machine learning scenario, if you want to do like, let's say, classification, you want to define a classifier. Like you want to divide, let's say, this entire data point, set of entire data points into 2 classes. Then you need to define a classifier, or maybe 3 classes. Then you need to define a classifier who will classify the data into 3 different classes. Okay. Yeah. So, and then here, these data points are, let's say, 2-dimensional vectors. In general, it could be n-dimensional vectors, which is a part of multivariate calculus. I mean, like multivariate statistics, okay, which is an application of multivariate calculus, which you will not do in this course, except the fact that you have 2-dimensional data, like a pair of random variables. But you can extend this into like any tuple of random variables. So this dimension could be n-dimensional, like 3-dimensional, 4-dimensional, so on. And then in that case, if you do a course on this multivariate statistics, or you can just read it by yourself once you do this course, then you'll see the main important point here is the application of linear algebra. Here we are doing the calculus, and there we'll use the multivariate calculus, which you have done in Math 2 and Math 2 or Math 1, and along with some application of linear algebra, because the data points there, okay, are some vectors. Okay, yeah. So we'll always start with let's say some PDF of something or PMF. So let us assume that there is a random variable. This PDF is like this, e to the power minus x. Okay, x bigger than 0 and 0 otherwise. This is my PDF. Okay, probability density function. Then the question is, let's say, the question is, so this corresponds to some random variable x, and I want to find out what is ex and what is the variance, like the sigma square x, okay, of that random variable. Okay, so one way to do it is like you just calculate its moment chaining function. Okay, because so here you can see, like, since it is exponential function, and in the moment chaining function, it is defined using exponential function. So maybe it is easy to integrate. So that's why your guess is okay. Otherwise, you could directly calculate. Okay, expectation means x fx. That also you can do, and then you can calculate x square fx. That also you can do, and then you can calculate expectation variance. But suppose I want to use moment chaining function, okay, to find out its expectation and variance. So then MT will be nothing but expectation of e to the power tx, and which is here minus infinity means here otherwise it is 0. So it is valid only when it is bigger than equal to 0 or bigger than 0. So this is e to the power tx, and then it's infinity e to the power tx times e to the power minus x, which will be minus of 1 minus t x dx. And if you just perform the integration, so this will be 1 by 1 minus t, and then e to the power minus e to the power minus 1 minus tx. I may be wrong in the calculation. Okay, but anyway, so this is, it should be 1 by 1 minus t if 1 minus t is bigger than 0. And so the expected value of this, okay, is ddt mt at t equal to 0. So you have to take a derivative of this, okay, and you can find its value. So which is 1 minus t inverse at t equal to 0. So this is 1 minus t to the power minus 2 at t equal to 0. So this is 1. Okay. Similarly, you can find out exponential expectation of square, the second moment, and then this is nothing but d dt. I mean, second derivative of mt at t equal to 0. So you will see that this will be 2 by 1 minus t cube at t equal to 0. So which will be equal to 2. Okay, so then the variance will be variance of x will be expectation of x square minus mu of x, the expected value of x, and then square of it. So which is 2 minus 1, which is 1. So basically what is happening is, if you want to plot it, okay, you want to just see it, and what is happening is, so if you just see, like, suppose this is mt will be some function, right? This will be some function mt, and then you can take m dash t, which will be, let's say, for this particular case, okay, this is an exponential function. That's why I'm drawing it like this. Mt is, no, this is 1 by 1 minus t. Okay, so that means 1 minus t is bigger than 0. Okay, I mean, anyways, so if you can draw this function, then you can have one more function m dash t. Okay, so these are the values basically. Okay, then you can have m double dash t. So these are the values which will give you the moments. Okay. Okay, so yeah, this is how you can calculate the different kinds of moments corresponding to this. And let me give you one more example. Suppose I know, sometimes what happens is, suppose I know the mg, I mean the moment journey function, and I have to calculate the PDF. Okay, that is also in some cases it is possible. Okay, I'll give you an example. Okay, let's say suppose let's say mt is equal to this. Moment journey function is equal to 5 by 15 some constant times e to the power t plus let's say 4 by 15 e to the power 2t plus 3 by 15 e to the power 3t plus let's say 2 by 15 e to the power 4t plus 1 by 15 e to the power 5t. Suppose this is the MGF, the moment generating function of a random variable, okay, of a random variable x. The question could be like, what is the PDF? What is the PDF? Okay, of x. What is that? Okay, so then the thing is, you see, from the moment generating function, okay, what is moment generating function? It could be, yeah. So for the case, since there are only finite many terms, then possibly you can see that, okay, if we just look at the definition here, it would be e to the power tx times fx, right? When it was, yeah, so this is the definition. Whenever you have e to the power tx, which is there actually, e to the power t, 2t, 3t, and so on. So that means x could be equal to 1, 2, 3, 4, and so on. And then there is fx, which is a constant value there. So it is of this particular specific form. So then you can probably write this as the sum over x belongs to Rx. So this is the definition, e to the power tx, okay, or you can just small x, e to the power tx fx. So, okay, then if Rx is some finite set, let's say x1, x2, xn, so this is, I mean, assuming that suppose it is some finite x1, because there are only finite many points there, which is I think 5. Yeah, so there are 5 terms here, so it can be like this. Then it is, of course, e to the power tx1 f of x1 plus e to the power tx2 f of x2 plus e to the power tx3 f of x3, okay, and so on. So e to the power tx4 f of x4 plus e to the power tx5 f of x5. Now, if you match this with the given one, okay, then what is happening is this x1 could be considered as 1, because if you put x1 equal to 1, then you get e to the power t. Similarly here, if you put x2 is equal to 2, then it will be e to the power 2t, and so on. Here you can assume x3 equal to t 3, then it will be e to the power 3t, and x4 equal to 4, and so on. So basically here the range set is, so this is actually a discrete random variable with the range set like 1, 2, 3, 4, 5. This is the range set, and f of x1, okay, is basically 1. X basically is basically this one, 5 by 15. So this is 5 by 15. Okay, so this is what is f1, and then you can directly write f2, which will be 4 by 15. 4 by 15. Then f3 is equal to I think 3 to 1. 3 by 15. 3 by 15. F4 is equal to 2 by 15, and F5 is equal to 1 by 15. So the question is, what is my PDF? PDF here is you can define a function, okay, which can realize these values at these particular points, like 1 to up to 5, and that's it. So this is, you can see x6 minus x by 15. Okay, when x is equal to 1, 2, 3, 4, 5. Yeah. So this is yeah. So sometimes you can obtain also the PDF from the NGF. Okay, that is also possible, specifically when you are dealing with discrete random variable. Okay, and one more thing I want to say that it is
Hello,
not necessary. It is not. Yes.
sir. How do you found out that this will be a discrete, or it will be continuous random variable?
Yeah, discrete means it had finitely many terms. Here the range space is finite, right? So when I expand this, okay, expand this, I saw that this is only finitely many terms here. It is the same form here. Okay, this is the same form here. T1, T2. So if you take different values of x1, x2, x5, then this is matching with this one. Okay, from that I interpreted that it should be the range set should be equal to 1, 2, 3, up to 5, and these are the corresponding values. Like this should be equal to f of, I mean, yeah, this should be equal to f of 1, and so on. So whatever is given from the problem itself, I have decided that this is of this particular form. So and the range space is 1 up to 5, 1, 2, 3, 4, 5, and that's how it is a discrete number from the specific form. Okay.
Okay, sir.
Okay. So now I just want to make sure one thing, like, I mean, I just want to note it down that MGF, moment generating function of a random variable, need not exist also. Need not exist. What do I mean by that? As I said before, like if you take the Cauchy distribution, okay, the Cauchy random variable, which you defined earlier, that was, I think, 1 by pi times 1 minus or 1 plus x minus theta whole square, or theta was a parameter. So this function is defined in terms of a sum or an integration, right? So it was defined. So yeah, it is defined as this way. Now the thing is, if x is discrete and suppose it is an infinite set, countable infinite set, okay, then this is a series, and the series need not be convergent. That could happen. Or suppose x is continuous and this integration is this function, like e to the power tx and fx, this need not be integrable. I mean, you cannot integrate a function. For example, what functions are integrable? I mean, if you remember math 2 or math 1 or maybe 10 plus 2, if this function has to be continuous, okay, then even if the function is discontinuous, you can also get, I mean, you can also integrate, okay, but assume that it is continuous, then definitely the integration will exist. Okay, discontinuous, even if the function is discontinuous, like it is about tx times f, then also you can integrate possible. For example, you can take a function like this and this, then this is the domain, let's say, okay, and this particular value, let's say it is up to, so let's say some 1, 5, and this is 10, okay. So you have this kind of function when x is from 1 to 5, and then there is a jump. So there is a jump, and the function is this, and at this particular point is actually, so there is, at this particular point there is a discontinuity, meaning, let's say this function, this is fx, okay, and then this is f1x and this is f2x, and it is defined like fx is equal to f1x. So this is f1x when, let's say, 1 less than equal to x less than 5, and f2x when x is from 5 to, let's say, 10. Okay, so this function is discontinuous at this particular point. Still, you can compute its you can evaluate an integration, because it is something with the area, as you know. So you can just add up this two areas, because at particular one point it is discontinuous. It does not change the area. Because area at a particular point is of course 0. So it does not make any sense. So you can just add up these two areas and you can find out its value. That is always possible. So if function is discontinuous, in fact, if it is discontinuous as countably many points, meaning at finally many point or countably infinitely many points, still the function could be integrable. Okay. So the question here is, if a function I have, a PDF I have, such that this is of not that type, okay, so this function is not integrable, then I would say that the MGF does not exist. Okay, so we are calculating MGF of a random variable, provided that I know the PDF or the PMF fx for the case of continuous or for the case of discrete. So when this exists, okay, then only I can find this particular function mt, which is a function of t. Otherwise, I cannot. For example, let me give you an example. Let us say I have a density function. I have a probability density function, which is like this. Our probability mass function, let's say, which is of this type. It's a 6 by pi square x square, and x equal to 1, 2. I mean, you can write it n also, doesn't matter anyway. So this is discrete. So this is my range set. So this is countable infinite set. In fact, it's at all natural numbers or positive natural numbers, let's say. And this is, and then if you want to calculate its its moment generating function, then it is of this type. Mt is equal to sum over x equal to 1 to infinity e to the power tx, fx, which is, let's say, which is what? Which is 6 by pi square x square. Now, if you do it, so then you'll see if I just take everything out, the constant, then it is e to the power tx by x square, x equal to 1 to infinity. And you can use the basic techniques, okay, to show convergence of the there are several tests to confirm the convergence of a series. If you use, for example, the ratio test, you will see, okay, that this sum does not exist. Okay, this is not a finite value. Okay, if this is not a finite value, it means it does not exist. The moments does not exist. Okay, or the MGF does not exist. So it has no moments. Okay, and for the case of PDF, you can also, I mean, for a continuous random variable, you can also see, like, if you define it like this way. So this is for discrete, one example for discrete random variable. Discrete random variable where MGF does not exist. Okay, a discrete random variable, and here also you can see some continuous example, continuous random variable. Okay, let's say fx equal to something like 1 by x square when it is from 1 to infinity and 0 elsewhere. Okay, and then you will see that you cannot compute the integration, so it does not exist. Okay. Okay, now I'll end this discussion of moment generating function with a theorem, which is a very important theorem. Okay, so as I said before, sometimes what will happen is, I mean, this is very important. Okay, this is very important. You'll see later also. Like, I mean, this is very, I would say, very natural question. Okay? In fact, somebody like, I think Laplace. Okay, Laplace said probability is nothing but study of common sense. Okay, so you are using your common sense, okay, to discuss some kind of an uncertain systems. Okay, so it is common. So it is like, okay, so suppose you have some random variable x1, x2, and dot xn. Okay, you have different random variables. Okay, we'll see some specific random variables, and then you have this corresponding, let's say, the PDFs. Okay, let's say f1x, for this it is f2x, and so on. Then the question would be whether these random variables are really independent, or these PDFs really independent, or they are somehow in disguise. One is actually the other one for some specific values. So, I mean, what I'm trying to tell you here is, like, if this for some values of x, okay, maybe it is equal to, let's say, f1 of some g of x, okay, where g of x, okay, let me denote the variable here, okay, f of this, and this is x2. So it could be possible, like, x2 is equal to some g of x1. Okay, so this is nothing but f of some g of x1. That can also happen. Okay, so whether one PDF is a function of another PDF or not. Okay, so this is I mean, this is an important question, whether all the random variables are independent or they are somehow connected. Okay, they are somehow linked. Okay, and you will see that all the specific distributions we will be talking about later on, they also, some of them, okay, will be connected or linked to each other actually. So here the question is, when I have this random variable x, then I can consider three different scenarios. One is, let's say I give a transformation like this, x plus a. This is a new random variable. Okay, this is a new random variable. From x, I'm creating a new random variable, x plus a. What is this? So random variable will take some, this is nothing but association with sample points, the real numbers with sample points. Okay, then here the association changes. Like, whatever the values are here, suppose if it is discrete x1, x2, xn, let's say this is corresponding to the sample points s1, s2, sn, then here what we are doing is we are taking x1 plus a, x2 plus a, xn plus a. This is what we are doing. So basically we are giving a transformation from x to x plus a. Okay, so this is a new random variable. Or we can scale it up like suppose b times x. That means what we are doing is if the sample points are associated by this random variable as x1, x2, xn, then we are multiplying this scalar b with all the xi. So it is like the range set of this one would be b times x1, b times x2, dot, 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 b times xn. Or we can have, I mean, a combination of both. So which could be like x plus a by b. These are very standard distributions. One is addition or just addition by fixed constant. It is scaling. And this is the combination of both. Sometimes it's also called translation. Okay, translation. So translation, this is scaling. And this is a combination of translation and scaling. So you are scaling it by 1 by b and translating as well as with a by b. Okay, so this can be 1 by b times x plus a by b. So you are doing it both here. Okay, then the question is, if I have this kind of a new random variable, then how the moment generating function of this new random variable are associated with the moment generating function of this. Okay, this will be particularly useful when we'll be talking about normal distribution, okay, or standard normal distribution. Okay, because standard normal distribution is a transformation of the normal distribution. Okay, we'll talk about that. So that's why it is important. Okay, sometimes you create new random variable using these simple operations, and then how things change. That's the question. How things change means how the expectation value will change, how the variance will change, how the different characteristic will change, how the moments will change. So in general, how the MGF will change. Okay, so if I know how MGF changes, then I know all other characteristics like moment, variance, and so on. Okay, so I can prove it, but okay, let's see. So then this is the idea, this is the theorem, like m x plus a t will be nothing but e to the power at times mxt. This is the moment generating function of x. Okay, moment generating function of x. Then if you take this translation of this random variable, okay, so then this is scaled by this e to the power at. Okay, if you take m times scaling of this t, so then this will be mx, and here it will be scaled. Instead of t, it will be b times t. Okay, and here if it is x plus a by t, x plus a by b, then it will be a combination of both. So which will be e to the power a by t times mx t by b. Okay, we can prove this quite easily, but let me just prove for this one, then others will actually follow. I mean, the similar proof. So what is that? mx plus a t. Okay, that means it is the MGF corresponding to the random variable x plus a. So this is expectation of e to the power tx. Okay, I mean tx plus a, right? This is this one. So then this is nothing but e to the power what is that? Tx, okay, plus ta. So it means e to the power ta. Okay. Now you recall that this is what we have proved earlier, that how this expectation will change when you take a scaling of that. So this also, or you can use just the formula to check. It is ta times expectation of e to the power tx, so which is e to the power at mx t. Okay, but proof is very simple. But these are the formula to remember, because suppose in a question, okay, there are some problems where you are asked to find MGF or some moment or some variance of a new random variable. Some PDF is given for a random variable X, capital X, but you are asked to find, for example, it could be what is the expectation of x plus 2. Okay, but you know the PDF of x. So let's say the PDF of x is this, and you're asked to find this. Then possibly you can find the moments, and from the moment you can take the derivative and you can find the expected value. Okay, or using the direct whatever the formula, you can also do it, or otherwise you can use the moment generating function to calculate the PDA, the expectation or the variance. Okay. Now what I will do is I will solve some specific problems, okay, for the purpose of this exam, so that you know what kind of problems you probably can expect in the exam. Okay, I'll try to solve some kind of problems. Okay. Okay, so maybe we can take a break for 2-3 minutes and then I'll start. Okay, we'll take a break for 2-3 minutes and then I'll start again. But I'll be here. Okay, I'll be here.
Excuse me, sir.
Tell me, saying something?
Sir, when you used to take the attendance, because
Okay, so
I
attendance is automatically it is generated by the MT Microsoft Teams. So I don't know
but
how
you need to download that. So
yeah.
so when you used to download that, I want.
At the end of the lecture.
Okay, sir.
Okay, I think we can start again. Yeah, let us discuss some problems. Okay, my first problem is like this. It's problem 1. Suppose I have a box where there are, let's say, 8 balls. Okay, and 3 are defective. 3 are defective. So I have 8 balls. Okay, and let's say 3 are defective. Okay, now I am asked to pick 4 balls, okay, from this box. Okay, pick 4 balls, okay, from the box. So the question here is, let's say, how many balls? Oh, I'm writing blobs. Okay. Anyway, it doesn't matter, whatever it is. So how many balls? So there's a spelling mistake here. How many balls Okay. How many defective balls, let's say, we can expect? This is the problem. So I have 8 balls in, let's say, in a, what is called, a box. Then I am asked to find out how many. You pick 4. Then how many balls you can expect that they are defective? Who can answer this? So this is an expectation problem in disguise. So if I want to calculate expectation, then I have to find PDF of a random variable. Now, what is the random variable here?
So number of defective
balls.
Okay, number of defective balls in 4 balls. Okay, number of defective balls in the 4. Okay, the set of 4 balls which if you, let's say, you have drawn or you have picked from this box randomly. Okay, so let's say X represents that. This is the number of defective balls, okay, that are picked, that are drawn or that are picked randomly, are selected randomly. Okay. Now, what is the range set of this? What is the range set? What are the possible values of this?
0, 1, 2, 3.
Yeah, 0, 1, 2, 3. They are the possible values. Now I want to calculate the PMF of this. So I want to calculate FX, because unless I know the PMF, I cannot calculate this expected value, right? So what is the PMF? So it is probability of X equal to X. So X equal to X here, meaning X number of defective balls. So what is this? Okay, I am randomly, meaning everything is equally likely. So it is what? How many ways I can pick 4 balls out of 8 balls? That is my sample space. And out of that, I'm picking X number of defective balls. Okay. So since there are 8 balls, okay, then I can choose in 8C4 OS. Okay. This is my sample space here. That these are the 4 balls. I mean, you can 4 balls. You can write B1, B2, dot, 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 up to B8. Okay. Now I am choosing my sample spaces. I can choose, let's say, B1, B2, B3, B4. This I can choose. I can choose B1. I mean, this is independent of the ordering, so I can also write a set here. Okay, this is a set of sets also I can write. But anyway, so B1, B2, B7, B8. Okay, and this way I can pick all the 4 balls out of those balls out of these 8 balls. So this is 8C4. Now what I need to calculate, how many of them contains, okay, X number of defective balls. And there are 3 defective balls, okay, 3 defective balls. So out of that, X means it could be 0 defective ball, or 1, or 2, or 3. All are defective. Okay. So out of this 4, okay, how many ways you can choose defective balls? X number of defective balls. This is 3CX. Now remaining balls are not defective. So remaining balls are, out of those 5, you have to choose 4 minus X. So this is the probability for P of X equal to small x. Now once we have that, then I can find out what is F0, which will be 3C0, 5C4 by 8C4. What will be its value? Okay, so when you are solving a problem in the exam, okay, so these are numerical values. So you have to be a little precise, because there is no credit. There is no marks associated with mistakes in the calculation. Okay, the final marks, the final value, the final answer has to be correct. So here, suppose in the manipulation here, when doing the calculation, if you do something which is incorrect, so you will get a wrong value here. Okay, so if you get a wrong value, then the entire calculation will be wrong, even if the rest is correct. Let's say everything is correct, but here suppose you have done a mistake. In the final value, there will be a mistake, and then you won't get a mark. Okay, so you have to be really, really careful when you are solving this kind of numerical problems. You have to really be cautious. Okay, if I do that, then what? Factorial 3, I mean, you can calculate it. And then what is that? Can anybody calculate and tell me what is the value?
1 by 14.
1 by 14. Okay, let us assume that it is correct. Okay, check 1 by 14. Then you can calculate F1, which will be something. Okay, F2, F3. Okay, F2, F3, some value, F4, some value. And then what we have to do is you have to calculate. Once you know this PMF, then you have to calculate the expectation of this, which is sum over x fx. Sum over x fx. And this x is from 1, 2, 3, 4. So x is from 0, 1, 2, 3. So then this is nothing but, yeah, f1, okay, plus f2, f2, because x is 0 means 3 of f3. Okay, so then you can find the value. So this could be a problem. Okay, I mean, there will be simple problems. Okay, the thing is you have to be a little bit cautious when you are calculating something. Okay, let me solve another problem. Okay, suppose this is my problem 2. Suppose you are given a PDF of a function fx. Fx is, let's say, something like this: 3x squared by t squared or t cube. Okay, when 0 less equal to x less equal to t and 0 otherwise. This is the PDF. Okay, and t is a constant. T could be 1, 2, 3, whatever. Depending on t, this is the PDF. Okay, t is some value which is positive, because otherwise negative, it doesn't mean anything here. Okay, t has to be positive. And the question is, what is the median? Median for this distribution, let's say. What is the median? So what is median?
So the 50th percentile.
Yeah,
of
50th
distribution.
percentile. Yeah, yeah. So basically, if I take this kind of a thing, suppose t is some constant. Let's say t equal to 1. Then this curve is like 3x squared. Okay. Then I have to find this value. What is the curve 3x squared? Y equal to 3x squared? 0. You have to find 0 here, and let's say t is something. Stay some. I mean, if you want to get a flavor of what we are doing, so it is 3 times x squared, or x is somewhere here from 0 to place. So this will be something like this. Okay, something like that. Let's say. Now, so you have to find a value of q here, which will divide the area into approximately into 50%. So this is 50%. This is 50% of the area. Okay, so you have to find the value of q. So according to the definition of the median, okay, so q should be is equal to half. This is half should be equal to, because it is 50, so 100 times p is equal to 50, so implies p equal to half. Okay, I mean, if you recall the formula which I discussed. So this is half, which is from 0 to q, fx dx. So fx we know, so this is 0 to q. Fx is 3x squared by t cube and dx. So this is 3 x cube. Okay, so this is x cube by t to the power 3 from 0 to q. So this will be is equal to q to the power 3 by t to the power 3. So it means what? Q is equal to 2 to the power minus 1 by 3 t. Whatever the value of t. So this is the value of q. So this is my median. This is my median. So there can be problems like this. And let us say some another problem. Okay. Okay. So in general, I mean, this problem can be a little bit critical. So you always have to remember the formula. Let us, I mean, I can just, let me do a similar problem. Problem 3. So let's say I have like, suppose fx is like this, half e to the power mod x. Okay. And it is from minus infinity to infinity. And the question is find 87.5 percentile of this distribution. And how do you find it? Okay, if you plot this function is mod of this. So it will look like if this is 0, it will look like something like this. Okay, something like this. Yeah, it is symmetric, but anyway, so it is something like this. So what should be the value of q here? This should be 87.5 by 100. This is how we got p, the p value, which is half here. So it was 50. Because of 50, it is 87.5. So this should be equal to minus infinity to q fx dx. Then you can use the symmetry of the function and you can calculate its value, the value of q that you can calculate. Okay. So this could be a problem. Okay. Another problem could be like this. Suppose you are supplied with this CDF of a function, CDF of a random variable. Okay. So suppose CDF cumulative distribution function. Okay. So CDF of a random variable x is given by this fx, which is equal to, let's say, 1 by 1 plus e to the power minus x when x is from this to this. And suppose you are asked to calculate. Okay, I mean the answers will be all numerical values. The question could be like, for what, let's say, for what values of, let's say I give some fx, which is like could be equal to some e to the power minus ax by 1 plus e to the power minus bx, or let's say just x whole square. So for what values of a, this is the PDF of this random variable. This could be a question. Okay, so there will be certain parameter, okay, whose value you have to calculate. Okay, but let us say that this is my CDF of this. Then the question is find the PDF in general. Okay, so
Sir,
what is the
if we
PDF?
differentiate f dash x and it is equal to small f of x, it will be the
Yeah,
process or not?
yeah. So yeah, so this will be like this. So we know how to, so fx is what? Fx is, we discussed it before. Fx is like probability of x less equal to x. This can be, so when it is continuous, x is capital X, the random variable is continuous. This can be computed using the PDF. Okay, so 0 to, let's say, x ft dt. Okay, this you can calculate. The CDF can be calculated from PDF, from the definition itself. But here, from CDF, you have to calculate PDF, which you proved during the lecture that it is nothing but a derivative of this. Okay, and for the case of discrete, you'll see there are some differences, like f of x1 is equal to, I mean, depending on small f of x1 is equal to capital F x1, then small f of x2 will be equal to like capital F x2 minus capital F x1 and so on. So you can see the lecture. Okay, so how to find PDF from the CDF. Okay, yeah, this could be a problem. Another problem could be, let's say this. Let's say the CDF. Let the CDF of a random variable x be given by this. Let's say it is a big function like this. So you always have to remember that whether it is discrete or continuous doesn't matter. This capital F is defined for all real numbers, for minus infinity to infinity. Okay, so it is defined like this: 0 when, let's say, if x is less than -1, it is 1/4. If, let's say, it is x is from -1 to 1, it is half. If, let's say, it is from 1 to 3, and let's say it is 3/4. Okay. If 3 less than equal to x less than 5, and it is, let's say, 1, if x bigger than 5 equal to 5. So if you plot it, okay, so -1 is here. So beyond this, it is 0, and -1 to 1 here, let's say this, okay, 1 is here. -1 to 1 here, it is, let's say, 1/4. So this value is 1/4. Okay, then this is 1, then this is, let's say, 3, then this is, let's say, half. Okay, let's say this is half, this is 1/4, and so on. So then this will be half, and then you have what, 5, then this is 3/4. Okay, somewhere here, and then it is otherwise it is, let's say, 1. So it is like this forever. Okay, so this is my, you can draw it like this, and draw it like this, and this is my fx. This is what is given to me. It is monotonically increasing function. And the question is, let's say, so this is the CDF corresponding to some x, random variable x, and you are asked to calculate, let's say, find this. Find probability of x less equal to 3. And what is its value? Or you can be asked, let's say,
F
probability
of 3 minus f of 0.
Okay, probability of, let's say, probability of x equal to 3. Then how do you find its value? This is more important than this one, let's say. So what is this value here? And what is the value here? Okay, first find out less equal to 3. Then what is its value?
3/4. Sir, it's
3/4.
only f.
Yeah,
of
so
3.
this is f3, which is 3/4. Now what is that p x equal to 3? Probability of x equal to 3?
1/4.
1/4.
1/4.
1/4. How do you get it? This is,
We can subtract it from the x less than or equal to 3 or x less than 3.
yeah. So yeah. So that's the correct answer. Okay, you can do that. Okay, so this is another problem. Okay. So let me
Sir.
talk about.
Hello.
Yeah. Yes.
Can we find EX or variance in this case?
What is that? EX, expectation value, and the variance. Yeah.
Yes.
So if you can. So for what do you need for expectation value and this? You already know the range set, right? The range set is what? In fact, this is a discrete random variable. So -1, 1, 3, 5. This is my range set. Now, if you know the range set, and then you just have to find the PDF, because if you know the PDF and the range set, then you can compute the expectation and variance, right? So from this CDF, you just have to calculate the PDF, which I discussed the formula, like the way you have done it here. So x equal to 3, you just have to calculate x equal to -1, x equal to 1, x equal to 5. Then you'll get the PDF, and once you get the PDF or PMF, and then once you get the PMF, then you can use the formula of expectation to compute its what is called the expectation. Yeah, and then similarly you can compute the variance as well. So for all these things, so whatever we have discussed basically in this course here, it's like if you have a random variable, okay, we are trying to calculate different properties of the random variable, which can give you insights about the values of this random variable. Like if you have, so random variable means what? There is some kind of sample space associated with the random experiment, and this sample points, okay, are associated with these numbers, and those numbers are given to you in terms of either an interval or in terms of some discrete set of points. So then we are trying to find out, okay, what is the average value, average data point. Okay, let's say if the data points are real numbers, then what is the average value of those real numbers? I mean, what you can expect. This is what is expectation. Varies means how much it will vary from the expected value, how long it will go. Okay, so this is Variance means it will measure, so which we discussed when we talked about variance. It will measure how much it will vary from the mean. Okay. So yeah, because mean is the variance is defined by what? The central moment, right? The second central moment. So variance was what? Variance of x or sigma square. It was expected value of x1, yeah, mu x square, right? So it's a second moment of second central moment. Central means this, you have to subtract this mu x. So this is second central moment. Yeah.
Sir, in above question, you have calculated P of 3. So P of
Yeah.
3, 3 by 4 minus 1 by 2 minus 1 by 4 or 1 by 2 minus 1 by 4?
F of 3 minus half, right? Sorry, minus 1, right? Because it is up to this minus this. What are the value?
Okay, okay. I have minus 1 by 4 also. Sorry.
Yeah, yeah. Okay. Okay, let us consider another problem. What is the problem number? Oh, I forgot.
Sir.
Anyway, so yeah.
Hello. Sir, how can you say like this will be a like discrete random variable here in the our problem?
Discrete, because this is how the effect shows, right? So it only increases at discrete values. So if you remember what is discrete random variable, if it has finite or countable infinite range set, right? So if you see here, this functions, okay? So what is the definition of this fx? I mean, if you take the corresponding random variable x, let's say here. So for this is f x less equal to small x. Now, if you take discrete values of this, then only you will get this kind of a function. There will be jump around this, and this is always monoton increasing. Otherwise, if you take this x as a continuous value, then this will be a continuous function throughout. Right? This x for different values of this will be totally a continuous value of this. So there will be no jump here. So the jump is happening because this x is discrete. So then something is getting added. Let's say x less equal to 3. And if we take x less equal to 4 here, for example, 4 does not have, it is not contributing anything. So that's why you have the same value here. If we take 5, then there is additional point here which is getting added, which is not constant, but it is, during this it is constant, but this f of 5, let's say, f means the density, the PMFF. So the probability at 5, it is adding something, right? So that's why it is making a jump. So at different discrete points, so this is making a jump. Yeah. So it follows from the definition. You just look at the definition and see how it is defined. Okay. So for example, how it is defined for the case of continuity. Okay. Continuous random variable. It is from minus infinity to x ft dt. So if some ft is given to you, okay, then this will be a new function of some function of x. Okay, this is some function of x. And if it is not continuous but discrete, then you will get a different value of x, that is addition of terms. Okay, and then you will have jumps here. Okay, then let us consider another problem here. Okay, suppose there are two boxes. Okay, so this is box one, and there is a box which is box 2. Okay, there is a box 1 and box 2. There are two boxes. Okay, and let's say the first box B1 contains 7 green balls and 4 white balls. Okay, and B2, it contains 3 green balls yeah, this is, let's say, 3 green balls and let's say 10 yellow balls. Okay, now you have to select one of these balls, B1 and B2. Okay, and let me say the probability, these are all, so I'm defining the problem, these are all given to you. Okay, that this ball, the first ball, let's say B1 contains 7 green balls, 4 white balls, and B2 contains 3 green balls, 10 yellow balls. And let's say the probability of selecting the box B1, the box B1 is 1 by 3. So then, of course, the probability of selecting the ball B2, the box B2, will be 2 by 3, right? Now, suppose there is a person who is blind, okay? So suppose, okay, I am blind, and so I cannot see, and I'm asked to say pick a ball. So there are two boxes, okay? Maybe they are placed on a table. Let's say they are placed on a table, okay? These two boxes, they are placed on a table, and I cannot see the balls, the boxes, but I know that there are balls in these boxes, and I am asked to pick a ball. Then the question is, okay, suppose suppose is given, another condition is given. Let's say this is a game. Suppose if I mean, let me make the problem more interesting. Suppose if I select a green ball, okay, then let's say I get, let's say 100 rupees. Okay, so the question follows. Question. So this is the scenario. I cannot see, but or my let's say my eyes are closed. Okay, so now I am asked to pick a ball. If I pick a green ball, then I win, let's say 100 rupees. And I have to pick the ball from one of the boxes, and there are probabilities associated with the boxes, whether I choose the box B1 or I choose the box B2. And the question is, what is the probability? What is the probability that I win 100 rupees? That means I win, basically I pick a green ball. How do I do that? What is my random variable, or what is the event here for which I want to calculate the probability? The event.
Green ball.
Okay. Then how do I calculate that? So let me define solution. Let
Sir,
A
we
be
can
the event. Just a minute. A be the event, which is what? Event for selecting a green ball. So I want to calculate probability of A. This is what? This is the question. Yeah, go ahead. What do you say?
sir, it's a question of total probability, so we can do it like that. First, we can go for first box and select a green ball, or we can go for second box, then we can select a green ball.
Okay.
Means
But
like total probability.
Okay. So if you just remember my picture for Bayes theorem. So I said I have a sample. Yeah. So I have a sample space. Here I also have sample space, and they are two different things. One is box B1, another one is box B2. Right? There are some balls here. Some of them are green and some of them are white. Okay. And here there are some balls, okay, which are green or yellow. Okay. Now I have to pick a ball from this. I'm picking something, let's say a green ball. Let's say I'm picking, okay, my probability, my event is here. Or maybe here instead of beyond B2, I could have written in here. For box, I wrote beyond B2. Anyway, so this event occurred. Then the question is, what is the probability of this event? So the event is A here. Okay, the event is picking the ball. So either then this is my event A, then it can have intersection is B1 because the ball I picked, it could be from B1 or it could be from B2. So it is A event. So it is nothing but A is what? A is equal to intersection B1 union A intersection B2. And these are disjoint event. So this is probability of, it will be just the addition. Intersection B1 plus probability of A intersection B2. Now, since this is intersection, by the way, you see from the problem, the probability of B1 is given. Means choosing, what is the probability that I'll choose B1? It is 1 by 3. So I have to use it somewhere. That's how it is given. And probability of then B2, choosing B2 is actually 2 by 3 because there are only 2 boxes. So now if we use the definition of conditional probability, this will be probability of A given B1 times probability of B1 plus probability of A given B2 times probability of B2. So I know probability. So what is the probability of this? See, I said we are picking it randomly. So A means what is the probability that I'll pick a green ball out of the balls in B1. How many balls are here in B1? Yeah, there are 11 balls. So what is the probability that I'll pick a green ball and 7 of them are green? So what is, yeah, 7 by, yeah. So it will be 7 by 11 times probability of B1 is given to me 1 by 3. Yeah. Plus similarly, how many are green here? 3 green out of 13. So this will be 3 by 13. Okay, times 2 by 3. So what will be the answer? By the way, in the exam, your answer should be a real number. That means you cannot write 7 by 11. Suppose, okay, let me calculate it. This will be 7 by 33 plus 2 by 13, right? Yeah. So, okay. So 33 into this. So it is that 9.
157 by 429.
Okay. 157 by 429. So now you cannot write this as an answer. Okay. That in the box, you cannot write 157 by 429. You actually have to compute it and find the real number expression for that. You have to use the calculator or your computer or any kind of software, whatever you have. So you have to use that to compute its real value in terms of decimal number. Okay. So once you calculate this up to 2 digits or 3 digits, it should be mentioned in the problem. But you have to write up to 3 decimal digits or 2 decimal digits. It should be there. So accordingly, you have to this. And you can of course round off, meaning suppose the answer is, I mean here this is not the answer, but let's say the answer is, let's say here it is 0 point something. Let's say 0 point 3. I mean, I'm just writing an arbitrary number. Okay, 3659. Okay. Now suppose you are asked to calculate up to 3 digits, 3 decimal digits. Then you can write 366. Okay. You can also write 3.365. Then also you get, because in Moodle, the correct answer is set inside a range. So if you write that inside that range, you will always get the marks. Okay, because Moodle will automatically calculate whether the value you're putting, this is inside some range or not. And in the question, so we had decided this range based on this round off. Okay, so it should be mentioned in the question whether you have to write 3 significant decimal digits or 2 significant decimal digits. And accordingly, you can round off and then you can put the value. Okay, so you should not write 157 by 449. You cannot write that. Okay. Okay, now let me add one more problem to this question. Okay, one more question to this question. So what is the probability that I win 100 rupees Or I can put another question here. This is question number 2. Okay. Suppose I win 100 rupees. Okay. Then what is the probability? What is the probability that the green ball was chosen from B1? So that means what I am asked. What is the what is the probability? What is the event which I am asked to calculate? Probability of which I am asked to calculate. What is the event here? So I win. That means I pick a green ball. Or what is the probability that it was actually chosen from B1? Because sample space was chosen.
Sir, we have to just apply Bayes theorem, sir. Bayes theorem, sir.
Okay, so what I'll do? So what is the event here for which I have to calculate the probability?
So just for P of B1 into P of A by B1, I think.
Okay, so what is the
Divided.
probability of B1 given A that I know because I win 100 rupees? Okay, that means this event has already occurred. What is the A? A is that event that I win 100 rupees, right? That's what the event A. Yeah, that is the event that I pick a green ball. Okay, now the question is, what is the probability that I actually chose it from B1? Okay, so then how to write it?
Sir, P of B1 into P of A by B1 divided by total probability of P of A.
Yeah, so this is probability of A. Probability of A I already have calculated, right? I already know this value. Probability of A. And this is given. So the numerator is nothing but probability of A given B1 times probability of B1. Because probability of B1 I already know. So I know this one as well. So I can compute the value here. In fact, you can draw the entire scenario, entire problem into a tree diagram. So this is sometimes you can also do that. So I have to first select a box. So I choose box B1 with probability 1 by 3. I choose the box B2 with probability 2 by 3. Then I choose. So this is my picture when you talked about Bayes theorem. Then I pick whether a green ball or whether let's say whatever the other ball, white ball. And then also here, and there is a probability associated, right? 7 by 11 because I'm picking randomly. I think 7 by 11 plus. Yeah, 7 by 11, that is 3 by 11. Okay, 3 by 30. So this is 4 by 11, and this is green ball, and this is yellow ball. So it is 3 by 11, sorry, 3 by 13, and then it will be, of course, 10 by 13. So this is the entire picture which I had drawn when we talked about Bayes theorem. Okay. So yeah, this could be a potential problem. I mean, similar to this kind of problem there you may expect. Okay, in the exam. Okay, let me discuss one more problem. Suppose, okay, suppose there are two dice. Okay, so let's say this is experiment. Let's say there are two dice, a pair of dice. Let's say a pair of dice. Okay, which are, let's say, four-faced, which are four-faced die, or four-sided, which are four-sided. So a die has 6 sides, right? You may also assume 4 sides. So there are basically 4 options. Okay. Now you roll this, both the dice, okay, and then you can calculate the sum. Okay. Dice and calculate. Then roll the roll the dice, okay, and calculate the sum of the outcomes. So dice means like, let's say the possible is like 1, 2, 3, 4. We have dice 1, okay. So this is a 4-faced dice. Somehow we had 4 faces, okay. So, and then there is a die 2. This is also 4-faced or 4-sided. Then once you roll that, once you draw that, then you'll get a value here. It could be 1, 2, 3, 4. It could be 1, 2, 3, 4. Then you're calculating the sum. Okay. The question is, what is the probability? So you keep on doing this. What is the probability that the sum 3 is obtained before 5 in the sequence of the rows? So what is that? So what is my sample? So sample space could be like this: 1, 1. You may get 1, 1. You may get 1, 2. You may get 1, 3. You may get 1, 4. You may get 2, 1, 2, 2. Okay, 2, 3, 2, 4. And these are all the possible values. So you'll have 4, 1, 4, 2, 4, 4. So these are all the values, all the sums, okay, for individual die. Then the question is, you can calculate what is the probability of having 3 as a sum. You also know what is the probability of getting 5 as a sum. What is the probability of having 3? Okay, so let me do that. A is the event, okay? A is the event which corresponds to the sum 3. And let B be the event, okay, which corresponds to the sum 5. Then what is the question here? What is the event for which you want to calculate the probability?
Event A occur before.
I can't hear anything. There is a lot of noise. What is?
Sir, P of A intersection B complement.
A intersection B complement. Okay, just a minute. Say, this is the question is, okay, you can switch off your microphone, okay? You can mute yourself. You can mute your microphone. Too much noise.
So that is not me, that is Sumit, sir.
No, I mean whoever is. It's too much noise. Okay. So yeah, so
hello sir.
Yeah.
So we can write like probability A given A union B.
Yeah. Okay. So I talked about this formula. If you remember it, I talked about this formula. So in a sequence of event, okay, which one will occur first? Okay. So I talked about this formula. So somebody said A this and somebody said A given A union B, right? So which one is correct or both are correct? Which one is correct? Or both are correct?
Both are correct.
So why the second one is correct, I can understand. But why the first one is correct?
So if B is not happening, then may A happen.
But both of them also need not happen, right? So the question is, which one is happening first? Question is not like which one is happening and which one is not happening. Question is, in the sequence of events, a sequence of draws or rolls, which one is occurring first? So if you, I think I had drawn a picture also, if you remember, a tree picture. So you start the process, and then you first time you play, then something will happen. Okay, because the picture will be big here, then all possibilities here it can happen. Okay, all possibilities. Then again, you can have some possibilities. Again, you can have some possibilities. In fact, I had drawn, suppose you have two events here, A and B. So either A happens at the first times or B happens, or both of them don't happen. So it is the complement of A and B. But I think I talked about a probability of R. Okay, if this happens, then either you can have A, again B, or its complement, and it's so on. And then I calculated the probability of occurrence of some event A before some event of B. Okay, I explained it, and I gave you a formula also, and then I showed that that formula is equal to this formula, probability of A given A union B, which also approved this to be equal to this one, probability of A plus probability of B. So it will be whatever the answer is. I can find out probability of A because I can just take the sum out of that, which will be 3. Then I can have the sum, which is 5, and then we can this we can have this value. Okay, this is the probability value. Okay, I think you can expect this kind of problems in the exam. Okay, and yeah, you have any question?
Sir, the last one, sir, could you please explain it again?
This one, this I explained already. You can see the video lecture. This I already explained in detail, how to get in the sequence which event will occur first, then the other one. This I explained. I think it was in lecture 3 or lecture 2. Okay, you can watch it again. Everything in details are discussed. Anything else you want to ask?
Sir, if CDF is constant over a given interval, then probability of X in between the interval is 0.
No, it depends. So that this is continuous or what? So can it happen for the case of discrete? Let's say, for the case of discrete random variable, can it happen?
No, sir. It is for continuous.
Okay, it is. If it is happening for continuous, what does it mean? That if you use the formula, okay. So if you use the formula, let's say it is from minus infinity to x, ft dt, or ft is the PDF. So your question is, I think, if the CDF is constant, then what is the PDF? If CDF,
yes, sir.
Yeah. So if this is constant, so that means it is independent of x. This is always a fixed value. Okay. And then what is this? Who can answer this question? Or you tell me what is the answer? If this function is independent of x, that means independent of this value, okay, then what will happen? Huh? So fx, yeah, go ahead. See, we said the properties of this CDF. One is if it goes to minus infinity, x goes to minus infinity, then we said something. What was its value? And if it is, if x is, if x goes to infinity, then also we set some value. If it is constant, will it satisfy all those properties? What do you think?
No, sir.
Then what is the answer? Can it be constant?
No, sir, not possible because value is changing at infinity and minus infinity.
Okay. 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 Anything else? Okay. So what we did basically here till now, I mean, let me just give a brief because we'll start another topic. So let me say what is the a brief review of what we have discussed. So we said let's say we start with a random experiment. Random experiment. Then we said, okay, it has possible outcomes. Then we talked about sample space. Then we said, okay, this objects here in the sample space, the objects here, the outcomes, or let's say the outcomes, or the sample points, is a better word. The sample points, okay, need not be numbers. Need not be numbers. Then we define what is called random variable. Random variable, which is of two types, of course. Random variable. Now we want to then what we talked about different properties, or let's say what we discuss is this is the question: how, okay, how do we quantify, okay, the elements or the properties, okay, the properties. Basically, I'm talking about how to calculate probability of events, okay. How do we quantify the properties of the sample space? This is what we discussed. And to do so, we defined some kind of characteristics of this random variable. So we defined what is called PDF. We defined what is called CDF. And using this CDF and PDF, we talked about mean, variance, okay, then percentile or quantiles, and then we talked about moments, and finally we talked about MGF. So these are the characteristics of the random variables. Okay, this is what we have done, okay, till now. Now what we'll proceed to do is we'll discuss specific PDFs. Okay, so basically for discrete or for continuous random variable, we'll consider some PMF or some PDF and find its properties. And why we'll discuss some specific, basically we'll discuss some specific functions, which are PDFs, okay, corresponding to some random variable. Sometimes we know how the random variable is could be defined, possibly could be defined. Sometimes we don't know. We know only the function, this function fx, and then we'll characterize, okay, or we'll determine the characteristics of the associated random variable, even if we don't know how the random variable is defined. But using the PDF, we can find its mean, variance, and percent, and so on. And then we'll show, not show basically, because in this course we'll not show, but we'll believe that this kind of PDFs will appear in real life. So we'll discuss some specific incidents or some specific random experiments where possibly you can encounter this kind of PDFs. So we'll talk about some spatial distributions, spatial probability distribution. Okay, so basically some special kinds of PDFs, some special kind of functions. Okay, and we try to justify ourselves that okay, these kinds of PDFs can occur in real life phenomena or real life experiment, and we'll possibly give some examples of some experiments where this kind of PDFs can be realized. Some spatial probability distribution functions. Yeah. So this is what we are going to do in the next week. So guys, all the best for your exam tomorrow, class test tomorrow. So yeah, so the kind of problems we discussed today, similar kind of problems will be there. Always keep patience, okay? And try to be, so you should not do mistakes in the calculation, okay? You have to be really, really cautious, okay? Yeah, anything you want to say? You can go ahead and tell me.
Sir, how many questions will be there?